Okay, back to another exam question video. So this is quite a tricky one, or this is one that some students will definitely struggle with. It's 4 marks, and it's saying to us, explain why methane and polyethene exist in different states at room temperature. So, first thing first, obviously if you've not done the organic chemistry unit yet, the methane bit you might not know what it is, although I would really hope that you do, mainly from Earth's atmosphere. And then if you've not done polyethene yet, then I guess you've maybe not done alkenes, or you didn't do it when you did bonding. Now, if you're taught by me, you'll have done both of them probably in year 9 or year 10. Okay? So the first thing I think is useful to do here is just recognise what these two things are. So methane is just CH4, right? And to be honest, I'm not necessarily getting any marks for this yet, right? But methane is CH4. It would look like that. If I were to draw the displayed formula of it, that would be the molecular formula. Okay, I would refer to this as it's a simple covalent molecule. Okay, it's a small molecule. It's not giant. It's not diamond. It's not graphite. It's not silicon dioxide. It's not any of those, right? It's a simple covalent molecule. Polyethene, on the other hand. Now, if you're good at doing the polymers, you'll get this quite easily, right? But polyethene is where I've polymerized ethene. So ethene would obviously be C double bond C, H, 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 like that. That's ethene. But if I'm going to polymerize it, I need my brackets. I need my C, C, like that. You've always got to have that format for polymers, right? It should always look like that. No more than 2 C's, okay? Students who do propene throw themselves off with that. Your H's move across, so H, 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 like that. You've broken the double bond because you've got the sticks going either side, and I'm having a little N there. That is a repeating unit of polyethene. Polyethene, though, is a massive, long polymer, okay? So, I'll write that there. So that's a polymer. Again, this probably, I haven't got any marks yet, which is why this question is quite hard. You've got to do this thinking either on the paper or in your head, right? So, it's asking me to say, explain why methane and polyethene exist in different states at room temperature. Okay, so the polymer will be a solid probably. Methane we know is a gas. Okay, right. All I've got to think about is this. What is it here that's going to influence boiling point? So if I boil methane, if I heat it up so it turns to a gas, do I break any of these bonds? No, I don't, right? So if you think about, if I boil water, it doesn't stop being water. It's still H2O. You haven't broken any bonds. So when we're doing boiling point or melting point, we're not breaking bonds. Instead, we are overcoming intermolecular forces, which is the forces between molecules, right? So if I had 2 CH4s, like that, I'd be overcoming these. I'm going to shorten it to IMF, right? But intermolecular forces, the forces between molecules. So, this is how I would structure this answer. I would be saying that methane is a smaller molecule. Obviously, you could say the opposite here. So you could say polyethene is a really big molecule, right? Or has much larger molecules. But I'm going to say methane is a smaller molecule. And I'm going to say that means that it has weaker intermolecular forces. Intermolecular forces. This point here is really important, right? So you can always say this when you're talking about boiling point. I can say here it needs or it requires less energy to overcome these forces, and therefore I have a lower boiling point. And so it's a gas at room temperature. Okay? There's not actually that much. These questions, they'll ask them in various guises, so they might compare like methane to butane, or methane to, they could even do something really mean like hexene, or something like a really long alkene. It's still the same. If it's a smaller molecule, it's got weaker intermolecular forces, and that needs less energy to overcome those forces. That means that you've got a lower boiling point, and so it's more likely to be a gas or a liquid, depending on what the boiling point actually is. Okay? Right, good. We'll leave that there. See you in the next one.